Welcome to One Off Coder. I'm Dr. G. Vang, and today I want to talk about list comprehensions. So what are list comprehensions? To me, list comprehensions are a way to transform an existing collection into a list. You've got to have an existing collection, and for some reason, you want to create a list out of this collection. There's many ways to skin a cat, so to speak, but using list comprehensions avoid verbose code. By verbose code, I mean code that is long. I'd argue if you use list comprehensions, your code will be cleaner and more beautiful. Others might say by using list comprehensions, your code is more Pythonic. Let's start coding to understand list comprehensions. We have a list of names here. If I ask you to loop through each name in the list and print them out, you'll most likely use a for each loop. Now let's spice things up a bit. Let's say I want you to create a new list from this list of names, where the new list stores the first letter of each name, the initials. How might we do this? We can use a for each loop. First, I'll create an empty list called initials. Then, I'll write a for each loop. Inside the loop, I'll extract the first character of the name and add that to the initials list. This is great, but observe that I needed 4 lines of code to achieve the goal. There's got to be an easier way, and that's with the list comprehension. The syntax to writing a list comprehension is very easy to understand. First, you'll need the square brackets. Square brackets are associated with lists in Python. You use them to initialize an empty or pre-populated list. Inside the square brackets, you have a for each statement. This is the looping part of a list comprehension. If you simply leave it at that, you'll get a syntax error. To the left of the for each statement, you need to have an expression. I call what's to the left of a for each statement the transformation part. Here, our transformation is slicing the name to get the first letter. And that's it. We assign the result of the list comprehension to the variable initials and print it out. Note that the result of the list comprehension is a new list. We can also transform a tuple into a list using a list comprehension. Here, we have a tuple of names, and we pull out the initials from the tuple of names. In this example, we transform a set into a list using a list comprehension. Since the iteration order is not guaranteed over a set, the resulting list of initials might not be in the insertion order of the set. Lastly, we can transform a dictionary into a list as well. The keys in this dictionary are names and the values are just numbers. I simply iterate over the keys and pull out the first letter of every name. I want you to see that we can transform lists of other things besides strings. I have a list of ages here. The elements are numbers. I can create a new list from this one. If I want the new list to have 1 added to each age, it's quite simple to do using a list comprehension. In the transformation part, I simply add 1 to the age. The other part of a list comprehension is the filtering part. The filtering part of a list comprehension uses an if statement to filter out elements. The if statement is written to the right of the looping part. I have a list of ages. Let's say I want to create a new list out of this one, but I want to keep the ages that are less than 18. The list comprehension would need an if statement at the end with a comparison to filter out for ages that are less than 18. We can change the filtering part to keep ages that are greater than or equal to 18. All I do here is to change the comparison operator in the filtering part. Here's another example of filtering the ages. I want to keep only ages that are even. For each age that I'm looping over, I check the modulus of that age by 2. This operation gives me the remainder. Any number divided by 2 whose remainder is 0 is an even number. If I don't like even ages and want to keep odd ages, I can change the comparison operator to a not equal comparison. I have a list of ages here again. This time, I want to create a new list where the elements are the age plus 1. But I want the new list to operate only over the odd ages. Observe the 3 parts of the list comprehension. The middle part, the looping part, is written as usual with a for each statement. To the left, the transformation part, I add 1 to the age. To the right, the filtering part, I filter to keep only odd ages. To me, it's more complicated to explain what I am trying to do than to simply just write and express it with the list comprehension. We can try to do the same thing with the map and filter functions. First, we apply the filter function to keep the odd ages. Then, of what remains, we map over the ages and add 1. Since the result of filter and map is a generator, we collect the outputs using the list function. We still get the same result with filter and map as we do with the list comprehension, but this is done using 3 lines of code as opposed to 1. Map and filter have their own use, however. If the list we are trying to transform and filter is huge, it's more efficient to use map and filter. In that case, someone might argue, use a generated comprehension. A generated comprehension is nearly identical to a list comprehension, except instead of using square brackets, we use parentheses. The outputs of a generated comprehension is a generator, not a list. To collect the results, we'll have to use the list function. We've got the basic understanding of a list comprehension. Let's add some twists. In a for each loop, we can enumerate a collection. We can do the same thing with a list comprehension. Here, I enumerate over ages and create a list of tuples. Each tuple will have an index and an age. Unlike odd and even problems, we have the list of ages here again. This time, I want to create a new list from this one, but I only want to keep the ages whose associated indices are even. You can use zipping inside a list comprehension. I have 2 lists here, one for names and one for ages. Between the 2 lists, each name corresponds with an age. Note that the resulting list is a list of tuples. Each tuple has a name and an age. If you don't like to create a list of tuples, you can also create a list of dictionaries. In the transformation part, I inline create a dictionary from the name and age pair. Here's a complicated list comprehension. I want to create a list of dictionaries through zipping over 2 lists. We've already seen how to do that. However, this time, I want to keep only those pairs of names and ages whose associated indices are even. To achieve this, I'll need to wrap the zip inside enumerate during my iteration. Look at my unpacking. I have to unpack what comes back from enumerate and also what comes back from zip. Let's say I have a list of lists, meaning there are sublists inside a single list. Here, I have 2 sublists of names inside the outer one called main list. I can flatten the nested main list using a nested list comprehension. The nested list comprehension reads, for each sublist in the main list, for each name in the sublist, pop out the name. The result will be a single list of all the names. The original list of sublists is said to be flattened. Notice that the for each statement follows one another going from left to right. If I didn't want to flatten the main list, but instead transform each element, I can write 2 list comprehensions together to do so. For this example, I want to create a new nested list out of the existing one, where each element will be the initial of the name. See how the transformation is a list comprehension and it is to the left of the main loop. Thanks for watching. We'd love to hear your feedback to create new and better content. Please contact us by going to our website at https://oneoffcoder.com. Until next time, happy coding and happy learning.